I will show you how a small change of just using parentheses instead of a square brackets can save us a tons of memory. Logically, this isn't possible with return because once the function returns a value, it exits. What if I told you there's a way to pause your function and pick up right where it left off? And it can give multiple returns like line 1, line 2, line 3. Now we have seen all the three lines. What if I call the next function again? Let's start with a simple code of list of squares of the numbers from 0 to 5. We will call this list as sq and then I into I4 I in range 5. What this line of code does is it generates a list of numbers raised to their own power from 0 to 4 since we have given range as 5. So we have used list comprehension here, which is a concise way to create a new list from an existing iterable. In our case, the iterable is range of 5. So let's see what this SQ variable holds. Oh cool, now this is square of the numbers 0, 1, 2, 3 and 4. One thing to notice here is that this approach of comprehension did all the computation first and stored it in a list for us to work with. Now imagine if we are working with some memory expensive thing, for example reading a huge log file or CSV file or calculating squares of some 1 million numbers, how much memory the list comprehension way will occupy. Now let's do the same thing but with one small change. I will show you how a small change of just using parentheses instead of a square brackets can save us a tons of memory. Let's rewrite this. Instead of a square bracket, we will give parentheses and we'll copy the rest of code here. And let's see what are the values in SQ variable now. What's happening here? Instead of a list, we got something different. What's that? It's a generator object. What's that? A generator is a function or expression, essentially an object. Since everything Python is an object, a generator is an object that processes an iterable one at a time, but only when requested. It's like a lazy version of list. Instead of storing all the values in the memory upfront, a generator computes them on the fly as needed. And to retrieve value from this generator, we can use next function. Let's try next of SQ and we got 0. If we do it again, we'll get the next number. Do it again, next number. Do you see the difference between first and second approach? The list comprehension did all the computation first and stored it in a memory, but our generator did not do the computation beforehand, instead waiting for our command to generate that to one value at a time. This generator just give one object at a time can save us a lot of memory and save us from real-time scenario like high CPU utilization and crash. So that was some basic idea of generators. Let's move on to another example. As we saw earlier, a generator can also be a function. So let's create a function which will give us some line maybe. And typically when we use a function, we have a return statement like this, return line 1. We will call this function, give line, and we get the line. But what if we want the function to return multiple values, like return line 1 and line 2 and maybe line 3 also? Still it gives line 1, right? Logically, this isn't possible with return because once the function returns a value, it exits. But what if I told you there's a way to pause your function and pick up right where it left off? And it can give multiple returns like line 1, line 2, line 3. Yes, that is possible, but instead of return, we will be using yield statement. So we'll copy this function code here and instead of return, we will use yield. Now we will call this function and we'll store the value in a variable, give a line, and let's see what does line has. Did we get our line 1? No, because when Python saw a yield statement inside a function, it converted the function into a generator automatically for us. And as we discussed before, generator does not actually execute right away. Instead, it returns a generator object. And since generator uses iterator protocol, we can use next on the generator object. Next of line gives us line 1. Again, if we execute, we get line 2. And this, after yielding, the function remembers its state, and when we call again, it will give us line 3. The difference here is, while return sendbacks a single value and exits the function, yield pause the function and remembers where it left off. The next time it is called, it continues from where it paused. Now we have seen all the 3 lines. What if I call the next function again? Let's try. Okay, this is happening because we have already yielded all the lines here, and now the generator object does not have anything to give us so it throws stop it error. Please don't ask me any other value now, I do not have anything to give it to you. But what if I do the same thing using for loop? What it will do? For L in line print L, line 1, line 2, line 3, and no stop iteration error. Why? Because as I explained in my previous videos on filter, what we did here, like next on generator. Next on generator for loop does internally for us, and it handles the stop iteration exceptions as well. The for loop exits when stop iteration exception occurs. Similarly, you can use generator functions to read huge file line by line. Notice how we are using yield statement here. The key advantage here is that the entire file isn't loaded into memory at once. Instead, the generator processes each line individually, making it perfect for handling massive files without crashing our system. So as you can see, generators allow us to handle large data efficiently by generating values one at a time. They keep our memory usage low and your code clean. If you enjoyed this video, please don't forget to like, share and subscribe. And check out my video on filter function. I'll share the link in the description. And stay tuned. Thank you.